What's poppin', dogs? Mr. Allen here. We're about to solve these rational equations, and we're going to list some domain restrictions along the way. All right, now this first one here, domain restriction, x cannot equal 6. And I'm going to solve this by multiplying by x minus 6 on both sides there so that the division and multiplication, boom, gone, cancel each other out. And I've got 3x plus 4 equals, I got to distribute this 5 in to get 5x minus 30. Woo! Awesome. Two-step equation now, baby. I'm going to subtract 3x, and I'm going to add 30 on both sides. Now I got 34 equals 2x, divide by 2, and I get x equals 17. And as we said, our domain restrictions here, x cannot equal 6. Since 17 is not that one right there, we are all good to go. Dang, that's awesome. Let's do another one. Let's do uno más. Domain restriction on this bad boy, I cannot equal 0 here in my denominator. All right, we'll list that at the end. So now what I got to do is I need to get, I think I'd like to get rid of my fractions. That's my plan here with this one. This first one was rather simple. I could just multiply by my denominator over here to cancel it out. And now I'm just dealing with a single line here, right? But this one, I got fractions, bro. First thing I'm going to do, though, I'm going to figure out my least common denominator. So I know I need an x. And then between my numbers, I got 2 and I got 4. So it looks like it's going to be 4x, right? That's my LCD. And I'll go ahead and just say x cannot equal 0 at this point. Let's get it out of the way while we got that going. All right. So my preferred method here is I'm going to multiply both sides of the equation by my least common denominator. And what that will do is we'll be able to get rid of our fractions here because multiplying by that least common denominator will cancel all those denominators out. They'll all reduce with each other, all simplify with each other. Whatever mathematical word you choose, they fit about to be gone. All right, so I'm going to multiply by 4x and by 4x and by 4x. Beautiful. So here, my x's, poof, right? And I got 12 divided by 2. That's going to give me 6. Beautiful. Next one here. My x's gone. And I've got myself 1 times 4, which is 4. And the last one here, I got the 4's, boom, out of here. And I'm left with 5x. Now I've got 10 equals 5x. If I divide by 5 on both sides, I get x equals 2. That ain't 0. So we all Gucci, dogs. 2 is my solution. It's not an extraneous solution. We'll see some extraneous solutions at some point, but not right now. Dang, dogs. That is super dang dope and awesome. Preferred method, find the LCD, multiply both sides by that LCD. And when I do that, I'm really distributing to each numerator here, right? Not the denominator. Some people are like, well, shouldn't I multiply the denominator too? No. If I multiply by 4x over 4x, I'm just multiplying by 1. I don't have to, That's not what we're doing, right? We're just multiplying by 4x. It's me hitting all of our numerators. That's dope. That's awesome. I'll see you dogs later.